So here on the back side, this is going to be super similar to what we did with long division, where we determined how can we decide if something's going to be worth dividing or not. It's going to be that same process. And this is called the remainder theorem. All right, it's actually the exact same thing, just phrased slightly different. So it says if you divide a polynomial by x minus a, which would make your root the opposite, which is why your root's just a positive a. So this is like saying if we divided by x minus 3, we'd be working with 3. Same concept, except it's just using the letter a. Saying if you plug a into your function, it'll tell you what your remainder is going to be. All right, and so that means if you plug in your number, if you plug in your root and you get a 0, you are safe to divide. If you plug in your number and you get a anything other than a 0, you would not want to invest in that division process. All right? But let's just go ahead and do the synthetic division here just to continue to get the practice, and then we'll see whatever the remainder is, how we could have determined that very quickly by just using this remainder theorem. We also will just do this by, later on as we get more complicated examples, we'll do this by graphing this guy right here, and we'll see does the graph cross over at 5, which is the exact same concept. It's just using the graph in conjunction with the remainder theorem, but you're always welcome just to do it numerically too. All right, so for our synthetic division, taking those coefficients, 1x cubed minus 5x squared minus 7, 25. Put our plus sign in here. Our root is a positive 5. First number drops down, multiplies by 5 to get back in. So a 0 shows up, and that'll happen sometimes. It's not a big deal. 0 times 5 is still a 0. So negative 7 would drop down, multiply by 5 to get that back in, to get a negative 35. And we are left over with a remainder of negative 10. Okay? And just to also continue to get practice, what this would look like for our answer would be x minus 5. And then we started off x cubed. So that means when you start off here, x squared, there's a 1. There's 0 x's. All right, there's 0 x's in here. And then that minus 7 with that remainder of negative 10. So we wouldn't be able to use this factorization for anything. But I just wanted to get us some experience and show, well, what happens when there's a 0 in there? There's just a 0 in there. We just don't write it. Okay? So now let's compute P of 5. Which P of 5 would be the same thing as F of 5. They just used letter P here. So I'm going to take my original expression, which was x cubed. And I can't see. I think that's a minus sign there. Okay. So we have minus our 5x squared minus 7x plus 25. And our root that we were working with was 5. All right, so 5 cubed is 125. So in this one, we've got 5 squared, which is 25, times a 5 that's negative is going to be a minus 125. So both of those just cancel out there for us. So we can go ahead and do that. Then we have negative 35 plus 25. And you see that we get that same answer of negative 10. This is that negative 10 that was also right there. So what we just did is we computed our root into the function to say whether it was even worth to divide or not. We want a 0. Right, so another way that you'll see us use this, like I mentioned, so I'll just kind of make a quick sketch. I don't know. It's going to give us a little polynomial here. All right, say this is one we'll be doing later on in the year, and we graphed it on our calculator, and we confirmed it crossed over like negative 7, positive 1, and let's just say 8. What we would do is we would use this basically as the remainder theorem. So whatever our original equation was, we'll end up having some options. We could choose to divide it by x plus 7, we'd be able to choose to divide it by x minus 1 or x minus 8. Because later on in this chapter, I'll just give you some kind of cubic function, or higher, I guess. And you could look at the graph, see where it crosses over, choose what factor you're going to be dividing it by. But all this is the remainder theorem. Because it's saying, hey, at negative 7, our y value is 0. Right? And that's what the remainder is. The remainder is what's your y value. And that's why all this stuff works and kind of how it all fits together on the grand scheme of things.